Welcome to the first internal training session of the Planets project. And next we are going to be looking into the actions within scoping as part of the SSbD workflow. And this is going to be provided by Sabine Hofer and Norbert Hofstetter from the Paris-Lodron University Salzburg in Austria.
Okay, so before we go more in details and for the newcomers of our community and potential beginners to SSbD, I want to make a step back to some basic principles how we should approach an SSbD project. As for any project, a plan implementing a well-reasoned structure is a key to success. Maybe you know Murphy's Law that says that anything that can go wrong will go wrong, should set the bar and the motivation very high to follow recognized guiding principles. With this in mind, it is obvious that the first step of a project, clarifying the context, setting the boundaries, defining the working space, and all involved actors is critical to establish credibility and accountability of outcomes at any later stage. A generic workflow, as proposed here, starting with scoping and ending in implementation, may be arranged along a linear flow of more or less distinct or overlapping tasks, covering the redesign of alternatives, structured assessments, but not limited to hazard of humans and environment, but also including questions of technical and economical feasibility and socio-economic impact. The results and options for action in between the steps are frequently ambiguous and afflicted with trade-offs. Thus, methodologies for multi-criteria decision-making have to be considered from the beginning. During the execution phase, knowledge gaps may emerge. However, clarification and more granularity of open issues may frequently suggest a change of your SSbD system definition, calling for a revisit of the scoping phase and re-entry in a circular manner. Managing data gaps and uncertainty as well as decision-making based on conflicting trade-offs is essential. While the phases, Martin, please click. Yeah. While the phases scoping and identification of alternatives or design or redesign of alternatives can be regarded as preparatory tasks, the SSbD assessment steps are at the centerpiece of any SSbD workflow. However, you should be aware the preceding phases determine the power and quality of the SSbD assessment outcomes in advance, because these likewise focus and also restrict the assessment working space and your potential perspectives. The assessment steps can be assigned to dimensions of safety and sustainability, which might not be equal weighted for an SSbD workflow, depending on your company's specific definitions of scope. The conventional approach of the past was, and still is, safety first. But with more emphasis on sustainability and life cycle thinking, the dimensions covering the environmental and social and economic impacts have to be set in place for an increased significance. Why, what, who, and how? These questions stretch and ring-fence the subject of matter of any SSbD project. A thorough definition and transparent documentation at this stage may be beneficial to improve the project's performance in all later stages. While the why, the design definition, and the what, the system definition, are frequently overlapping, the roles and expertise of the who's, the actors in a life cycle, are more apart. Creating awareness for needed subject matter experts, identification of relevant stakeholders for decision-making, their contribution to acceptance and implementation needs early inclusion of inside and outside human resources. Of important note, decisions on how may be the most relevant consideration in regard to the potential outcomes, because the decision on available or intended to apply methodologies opens or limits the depth and breadth of any investigation, but have also to be aligned in the view of an acceptable overall balance of benefits and associated effort of a project. The scoping phase has also to bring forth a decision on your preferred options for action. Redesign elimination, substitution, or change are applicable action elements of any stage of a substance of concern involvement in its production, use phase, and end-of-life cycle. Although looking for drop-in replacements following the minimax principle, I don't know whether you heard this forever, this means minimizing your change to maximize a very local key performance indicator is intriguing. However, this approach delivers the least contribution to innovation, potential market advantages, and long-term sustainability. Thus, the scoping phase should be used as a first opportunity to decide about the potential reach of your SSbD project, questioning possible solutions not limited to the substance level, but instead being open for action and design or redesign on material levels, product level, process level, and also questioning the need of the function itself, or going further by replacing a complex system while still achieving the desired function of the product for the market.
So let us switch to me and let us now take a closer look at the scoping analysis. As we heard before, it represents the first step of the SSbD workflow and should answer the question about why, what, who, and how. It is a critical step which decides about the quality of the assessment results. Here, the company's very specific perspective comes into play. This step defines and documents the goals, principles, decision rules, also the SSbD rules and principles, and will guide all of the following steps in the assessment and thus the outcome of the assessment. All decisions made here have to comply the regulatory landscape, hence it has to be specified also here in the scoping phase. The scoping step includes the characterization of the substance of concern. Understanding its key properties helps to design alternatives, and physical and chemical properties have to be determined, completed by the specification of the function the chemical serves in this application or product, performance requirements, potential exposure pathways, intrinsic hazard potential, and life cycle impacts. Appropriate stakeholder involvement needs to be considered also already in this step, which has to include all the actors who are expected to contribute over the whole life cycle, and as well as all groups affected. Methodical approaches in regard to all assessment steps need to be determined at this point. Alternatives identification and design, hazard and exposure assessment, feasibility and performance assessment, and decision strategies. The evaluation of each criterion and the decision process can be performed following different decision-making techniques. It can be done sequentially by each dimension, which may save time because you can rule out bad performance early in the process. Carla already mentioned it. It can be done in parallel with the advantage that you can you do not exclude or some alternatives too early, or it can be done by a mixed hybrid model. Next slide, please. Not to forget, in the context of methodical approaches, is the decision about how you intend to deal with uncertainty, data quality, and data gaps. Especially in the tier 1, you will have many data gaps. Different strategies may be suitable for different tiers of the evaluation project, and these will differ in effort and quality. At this point, the company has to decide about the trade-off between effort and acceptable uncertainty. Potential strategies range from remaining neutral about data gaps, excluding alternatives with missing data, the application of additional tools such as QSA, quantitative uncertainty analysis, up to the most time and effort intensive ones, which involve additional tests, studies, or prototyping to reduce uncertainty. Next slide, please. If possible, the scoping phase should already include concepts concerning the decision rules which will be applied. All information collected in the assessment steps will have to be integrated in a multi-criteria approach, which should lead to a ranking of your designed alternatives. The final decision will represent a trade-off between the different dimensions, dependent on the weighting you assign to the individual criteria. As an example, here, you evaluated in your assessment the physiochemical properties, the specific hazard characteristics, the exposure potential, life cycle trade-offs, technical and economic feasibility, and the availability of competencies. You measure then the individual alternatives for each criterion by a benchmark, frequently your own substance of concern or a state-of-the-art market solution. Next slide, please. As already discussed, you can apply several decision strategies for the assessment of trade-offs and the consideration of data gaps and data quality. Here is an example for a general approach. Let us assume we have 3 pre-selected alternative designs, each assessed for our evaluation criteria, graded and weighted according to company's individual relevance. The grade in regard to data gaps and quality of data completes this scoring. This approach, based on a more or less complex decision algorithm, results in a score for each criterion and a total score for each alternative design, and allows finally to rank all these alternatives. Next slide, please. How is this scoping phase now implemented in the JRC SSbD framework? The framework recommends that the SSbD workflow should always cover the three SSbD system elements. First, chemical material. Second, processes, including not only the production process, but also processes applied for the end-of-life management. And third, the product or application. These 3 elements have to be considered in both the definition of the system under study, as well as the redesign definition, which includes the task's purpose and principle definition, and the redesign of the molecules, processes, and product. Next slide, please. As an example, let us look at some questions which could be asked in the system definition section. First, chemical and material. For example, is the chemical material known? If no, further information has to be gathered and discussed with internal and external specialists in the value chain. If yes, what is the name? In which composition? And do we have detailed data? Do we have more information? Similarly, the question concerning the processes. For example, are they already known? If yes, is the chemical used during the production process, and will it be part of the product or not? Or will it only be used during the production process? Next slide, please. Last but not least, the questions concerning the product or application. If it is already known, can we describe the product? What is the associated industry sector? What is its function? In our later hands-on session, we will go through the exemplar questions for redesign and system definition based on a fictive case study. And last slide, please. SSbD is a tiered and iterative process. In the course of the definition of the system boundaries and the assessment itself, you will gain more and more information, knowledge, which potentially will lead to the necessity for changes in the initial system. This may apply to one or all three elements: chemical material, processes, and product, which means that some steps will have to be reiterated, as indicated in Norbert's slide, where SSbD is shown as a cyclic workflow. Yeah, let us now look at the direct implementation of the scoping phase in Planets project and practice it by means of fictive case study in our hands-on session.
Thanks,
Yeah,
Sabine
thank
and
you,
Norbert,
Sabine.
for this. And yeah, over to Josephine. Sorry that I just interrupted you. Josephine, is yours.